For this oblique triangle, you can see that the height of it is going to be y, which creates a right triangle here, and of course also a right triangle here. And if this distance here is x, this distance between the vertex A and the height y, then this distance here is going to be c, which is the full distance, minus x. And I can do the Pythagorean theorem on this right triangle to get this statement here. Simplifying this, I'm going to write it like this. I'm going to expand this squared term to give me c squared plus x squared minus 2xc. And I can use the right triangle trig on this other right triangle to simplify it further. X and y are the inside measurements of this triangle. I want to only work with the side measurements a, b, c, and the angle measurements capital A, capital B, and capital C. So I'm going to try and get trig functions that can remove x and y. So looking at, I can't really do trig on this angle because this angle is not the full angle C. C is this full angle here. And that's not a part of this right triangle. So the only right triangle trig I really want to work with is this right triangle on A. So cosine of A is going to be adjacent, which is x, over the hypotenuse, which is b. This tells me that x equals b times cosine A, and sine of A is opposite, which is y, over the hypotenuse, which is a b again. That tells me that y equals b times sine A. I know what x is and I know what y is. Let's plug them in here and see what we get. Y is b sine A. This is squared. Plus c squared plus x is b cosine A squared. Minus 2 times x. X is just b cosine A. So I want to write this as bc times cosine A. That c was already there. I just moved it around a little bit. And I get b squared sine squared A plus c squared plus b squared cosine squared A minus 2bc cosine A. Okay, now b sine squared A and b cosine squared A, I can rewrite that as b squared sine squared A plus cosine squared A plus c squared, and then plus, or I should say minus, this final term, 2bc times cosine A. Sine squared plus cosine squared, this is always equal to 1. 1 times b squared is just b squared. And this is the law of cosines. Now, I used the orientation of the triangle that was given to me, but you can reorient the triangle and do the same thing. So the full law of cosines is this entirety thing, where the most important thing to notice is that the angle the side length you're solving for is the angle inside the cosine. So if you have b squared, which is equal to, then b is going to be inside the cosine. If c is there, then c is going to be inside there. And you always have a squared b squared and then 2ab, or a squared c squared 2ac, b squared c squared 2bc. That's the idea for law of cosines. And these work very, very well for side, 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 and side angle side scenarios. So let's take a look. We have a surveyor is measuring from this point. He knows it's 800 feet to this point from the lake, and then 900 feet to this point. And he also knows that there's a 70-degree angle. So with this information, what's the length, the distance of the lake? Let's label this AB, So we're looking for this distance here, A to B, and this one must be C. So this is going to be little c. That means A is here and B is here. Okay, this is a side angle side, and this is perfect for law of cosines. So law of cosines says c squared equals A squared plus B squared minus 2 times A times B times cosine C, the angle opposite the side we're trying to find. That's all I've done here is just use this portion of the formula. Okay, and simplifying that, I can do a lot of work on my calculator. 978.51, and this is going to be in feet. Now, Los Angeles is 1,744 miles from Chicago. So Los Angeles is here. See if I can draw a straight line to Chicago, something like that. This is 1,744 miles. And Chicago is 714 miles to New York. It's right there. 714. Of course, I'm drawing a straight line that might not be, exactly what it is, but if you're driving along the roads, but let's just give it a good estimation. New York is 2,451 miles from Los Angeles, so draw a triangle there. We have an oblique triangle. It's not a great triangle that for my drawing, but it serves the purpose. Find the angles in the triangle. That's what we're trying to look for here. To do this, all we have to do is find one of the angles, and then we can use law of sines. To find one of the angles, law of sines does not work because we have only the side lengths. We need to have an angle to use law of sines at least. Law of cosines, however, does work for 3 sides. So let's name these things. Let's name it A, B, and C here. That means that this is going to be A, or lowercase a. This is going to be lowercase b. This is lowercase c. Okay, it doesn't matter which triangle we solve for, or sorry, which angle we solve for. Let's just solve for one. So let's just solve for A. So A squared equals B squared plus C squared minus 2 times B times C times cosine of the angle we're looking for. That's what we're trying to find. So we can rearrange this, of course. That means cosine A is going to equal this is what cosine A equals. So let's actually plug that into a calculator and get what we get. And we get, let's see, just about negative 0.986. Doing the inverse cosine is going to give us 170.47 degrees. Quite a large angle, which is what we expect, though, because Chicago and Los Angeles, or Los Angeles and New York, are so far apart from Chicago. Chicago's kind of right in the center. That this is a very large angle, about 170 degrees. So that seems reasonable. Okay, now we need to figure out what are the angles here and here. And we still need another angle. So what we can do is we can do law of cosines again, but just rearrange which ones we're looking for. So here we solve for A. This was A squared. Instead, let's solve for B. So let's do B squared. B was 1744. Is going to equal A squared plus C squared minus 2 AC cosine B. And we can do the same process again. We're going to solve for cosine B. Okay, and that's going to give us that cosine B equals 0.993. So B equals 6.76 degrees. Very small angle. And that means that C must equal 180 minus 170.47 minus 6.76. So C equals 2.77 degrees on this triangle. So now we found all of the, we've actually solved this entire triangle now. All right, with the law of cosines, we can complete the table. Law of cosines works great for side, side angle, side. And then you can actually use law of sines in conjunction with law of cosines. Typically, you have to use law of cosines first before you can do anything else. Then law of sines tends to work out nicely. Instead of doing this, this second application of law of cosines here, I could have done law of sines. Since I knew an angle and a side opposite, I could have done, sine 170 over 2451 equals, let's say, sine of B over side length B is 1744. And with that, I would have gotten the same answer. I should get the exact same answer as this. And then I could use law of sines again, but of course, this is much faster. Just use that whenever you can. All right, give it a try in numbers 1, 2, and 3. As well as number 4.